What do you know about a theorem and a postulate?
Theorem has to be proven. Postulate is obvious.
So write this down. A postulate is totally accepted without proof. Why do we accept it without proof? Because it's pretty obvious. It's accepted without proof. So we accept it without proof. It's truth. What's the theorem? It's not as obvious. A theorem is something that's got to be proven. Must be proved. So this whole chapter, we're trying to prove the two triangles are the exact same triangle. If they're congruent, they're the exact same triangle. Devin, you know two ways that you can prove triangles are congruent from 4.3. What are they? Alright, side, side, side. So if you have three sides that correspond and are congruent, it's the exact same triangle. And if you've got what? Side, angle, side. If you have a side, an angle between the sides, and another side, then those two triangles are the exact same triangle. So Ricky, all they do is flip them, turn them, rotate them, twist them, but they're the exact same shape and size. So today's two new ones. Okay, now what's interesting is this. Here's what's interesting. This one is a postulate, which means it is obvious, but this one is a theorem, which means it's not as obvious to see. So some guy said, you know what, I'll bet you if you give me an angle, and a side that can match up and are congruent, I'll bet your triangles are congruent. But this one's not as obvious, so they had to say, prove it. Show me, what's your proof? This one is accepted without proof. If they give you an angle, a side, and an angle, and they correspond with another triangle, that means every other piece and part corresponds and is congruent. Write this down though, underline this. That's the trick.
So on our homework when it says like write the postulate,
Yeah, why?
do you just write ASA?
ASA. Just write ASA. Yes, abbreviate. But ASA only works if the S is the included side. What does the included side mean? It's got to be sandwiched, just like they write it. Angle, then a side, then an angle. So Burgundy, look at this. Angle, the side's got to be in between it and the other angle. Yes, it's got to be on the same line. Sweet. No. Good question. But here's what you know. Burgundy, if you know the angle A matches up with angle D and angle C matches up with angle F, and this side matches up with this side, what else do you know? What else do you know? You know that DE matches up with AB, BC matches up with, and what else do you know? That's given. But you know this angle. So they are only giving you minimal parts. They're going to give you three things, but you know the rest of them must match up. So this one, the angle side congruence theorem. Here's what they say now. You know what? I can give you an angle, but that side does not need to be sandwiched between them. If I give you an angle, and then a side that's not sandwiched between, they are still the exact same triangle. So do you agree that this is easy to see and this is hard to see?
Yes.
Devin, in your bag of tools, you got 4 things you can bank on. You can bank on the side postulate, the side postulate, the angle postulate, or angle side theorem. So it's got to be one of these 4. So look at number 7. Is it possible to prove these triangles are congruent? Yes or no? So what do they give us on 7? Okay, they give us an angle, y matches up with f. They give us a side, ly matches up with fl. What else do they give us? Where's the other side? Okay, wl matches up with itself. So they gave us a side, and an angle. What can we use? Can we use any of those? Can we use side, angle, side? Why can't we use side, angle, side? Because the angle, if we're going to use side, angle, side, if they're giving me this side and this side, the angle's got to be that one. And it's not. So 7 is no. Okay, let's look at 8. Alright, what do they give us on 8? Okay, they give us the angle T matches up with angle U. Side NS matches up with side HS. What else? Now there's a vertical pair right here. You got, let's do 2 arcs. Draw 2 arcs. So angle TSN matches up with angle HSU. So what can we use? Yes. So you could use this guy. Angle, side theorem. Okay, number 9. Oh, 9 looks kind of funky. So now we're starting to get into some good geometry because they're leaving stuff out. They left out this vertical pair. They left out this WL. What do they leave out in 9? They're going to leave stuff out. What do they leave out in 9? You do know. Why do you know that that's also right? Because it's 180 degrees. So if this guy right here is 90, on a straight line there's 180. So this one by default has to be 90. So what do they give us? Okay, angle KHN matches up with, this one's not given. So these two match up. These two match up. So the answer is yes. Angle, side. Alright. 7 is no because they gave us, here's what we got. We've got an angle, and we got a side, and we got a side. But you don't, you gotta be, you can have an angle, a side, and a side, but it's gotta be either the angle, the side, angle, side, or the angle, side, side. No. Angle. That's because you messed me up. You got in my head. It's got to be one of these two. Your angle's got to be sandwiched between them, or you've got the side sandwiched between them. Okay, number 10. What's funny, Eddie? I know. That is funny.
So when people come on, they're gonna be laughing. You're like writing it.
Here we go, Eddie. Draw a table. And let's go on the left. Let's put statement. On the right, put reason. We'll listen to it. On the left, put statement. On the right, put reason. Here we go, Burgundy. You got it. You got to do this on your homework. Maddie, you got it. Statement, reason. Here we go. Your objective is this. Prove that these two triangles are congruent. So you're going to have to give me step by step by step. So I need 3 things. Side, side, side. I need an angle. I need something. So what do they give me? What do I got? Okay, now hold on. Line AB. Let me show you the trick. What does AB match up with? Do not look at the picture. Do not look at the picture. Look at this. It has to be in order. If you're going to go from A to B, you have to go from, it's got to be line EB. Does that make sense? Don't look at the picture. Look at this. Now, why do I know they're congruent? Given. Good. Reason is given. Alright, BD. So let's go this. BD. Now, if you're going to choose BD, here's what you chose. You chose BD. Yeah, you got to choose BC. And it is, what's the reason? Given. So, I'm missing the third, either a side or an angle. Hold on. How do you know AD is equal to CE? No, it's not given. Or else it would have the congruence marks. And there's no way to prove those two are the same length. No, that's what we're trying to prove. We can either prove it yes or prove it no. Okay, there we go. That's what we know. We know there's a vertical pair. So you got to write this. Now hold on. That's angle B, right? So I'm going to write angle. I can't write angle B because I don't know if it's the left or the right. I've got to go angle ABD. Angle ABD is congruent to angle. I have to go EBC. EBC. Why do I know they're congruent? The reason is this. It's a vertical pair. And then your final statement is going to be this. The proof. I know that triangle ABD is congruent to triangle EBCY because I've got a side angle side. Side angle side.